Now that you've had a chance to work with some mathematical statements, we're going to do some more advanced things with them. In particular, we're going to look at operations on statements. So we're going to define what a logical connector is. We're going to define the or, and negation operations. We're going to introduce the use of models to help us understand various concepts. We're going to explore how conditional statements work. What I mean by that is if-then statements. We're going to look at how negation interacts with different logical operators. All right, so a logical connector just takes one or more mathematical statements and then transforms them into some other mathematical statement. So we've already seen one of those, the OR connector from the last video. The way this works is if you have two statements P and Q, you can connect them using the statement P or Q. This new statement is going to be true if either one or both of P and Q is true, and it's going to be false if both P and Q are false. The next one we're going to look at is the AND operator. So you take two statements P and Q, and you combine them using the statement P and Q. This is going to be true if both P and Q are true, and it's going to be false otherwise. In other words, if one or both of P and Q are false. Some logical connectors require only one statement. We've seen a couple that require two. This one only requires one. It's called the negation operator. So if P is a statement, just one statement P, the negation of P is written not P. Now this one is just going to flip the truth values of our statement. It's going to be, not P is going to be true if P is false, and it's going to be false if P is true. So to look at an example, if I take the statement, I am sitting down, if I want to negate that statement, all I have to do is say, I am not sitting down. If I am sitting down is true, then I am not sitting down is going to be false. If I am sitting down is false, then I am not sitting down is true. Negation can be a little bit complicated, especially when you're dealing with molecular statements that are comprised of more than one statement. So for instance, if I have the statement, I am in the kitchen or I am in the living room, a question is, how do you negate that? How do you find the negation of that statement? So I can give you a cheap answer. It's not a very satisfying one. I could just say, it is not true that I am in the kitchen or I am in the living room. While that's technically the negation, it is not particularly helpful. Remember, you want to be very clear in what the statements say, when the statement is true or when it's false, and all you are saying, hey, figure out what's going on in that previous statement and, not that. Again, not helpful. But to get a more helpful version of this statement, I'm going to need a model for how to understand negations. So a model, I'm going to be using models a lot in this course, and all a model is, it's a way of understanding a concept, an abstract concept, in a more concrete way. So one way of understanding negations of statements, we are flipping the truth values. We're changing true into false and false into true. So one way of thinking about how negation works is just a statement that describes precisely what it means for the original statement to be false. So in order to do that in a statement like, I am in the kitchen or I am in the living room, it might help to think of what is going to actually make that statement false. Well, a couple things are going to have to happen, and these absolutely have to happen. First of all, I can't be in the kitchen. If I am in the kitchen, no matter what is happening in the world, that statement is going to be true. So I can't be in the kitchen. And the second thing is, I can't be in the living room for the same reason. If I'm in the living room, that statement is going to be true no matter what is going on in the kitchen. And not only that, both of those things have to be true. And that may sound a little bit familiar, because when I say two statements, both of which have to be true in order for things to be true, that's an AND statement. So if I want to negate I am in the kitchen or I am in the living room, I have to say I am not in the kitchen and I am not in the living room. And that describes precisely what it means for the original statement to be false. All right, so if I want to talk about this, now I want to talk about conditional statements. These are going to be extremely important statements for you as computer science people because if-then constructions happen all the time in code. So a conditional statement is a combination of two statements. You have P and Q are two statements, and it looks like if P, then Q. So just like any other construction, we want to be able to describe when the conditional statement is true and when it is false. And this one's a little bit tricky and in some ways counterintuitive if you just sort of say what the rules are. So I want to sort of get some understanding of how these things work using a model before we talk about when it's true and when it's false. And in this case, I want to take a step back and make a fundamental model about just mathematical statements in general and when they are true and when they are false. And I'm going to call that the liar model. Now, one thing that can really be a sticky thing for us to think about in terms of when a statement is true is we see the word true and we think of that as a very virtuous word, right? We are saying something like we're good people when we say true things. And I want to lower your expectations about truth in statements, and we're just trying to avoid being liars. So a statement is true not when we say we're good people when we say it, but when we are not lying when you say it. So we're just avoiding lying. We can be horrible people otherwise, but we just can't be liars. And a good way to think about this in terms of conditional statements is something I call the cookie model. So maybe my children are having trouble behaving themselves, and so I tell them, if you behave, then I will give you a cookie. You can argue about whether that's good parenting or not. Well, we can have a discussion on that. But let's just look at that particular statement, and in particular, try to think about when it's true and when it's false. So the question is, again, when am I lying and when am I not lying? Well, in order for me to be lying, something very specific has to happen. Two specific things. First of all, you have to behave, or my children have to behave, but I don't give you a cookie. If you behave and I don't give you a cookie, not only am I a bad person, I am a liar, right? Because I told you, if you behave, then I'll give you a cookie. Now the question is, well, when is it that I'm going to be telling the truth? And the answer is, if anything else happens. And this includes when you don't behave, but I do give you a cookie. And you can argue in that situation, I'm not really helping anybody behave by giving them a cookie when they don't behave. But again, this isn't about me being effective in my goals. This is about whether I'm telling the truth. And if you don't behave, I haven't told you anything about what happens when you don't behave. So I can give you a cookie, not give you a cookie. Nothing is going to make me a liar. Another way of thinking about this is a more computer science way of thinking about this is what I call a conditional pass model. And so what you want to do in this one is think about what happens if you have an if-then construction in your code, right? A conditional statement is going to be true if we can effectively pass through that code to the next line of code. Right? And this can actually happen in two ways. Now, if you get to an if-then construction and the if part happens to be false, then what's going to happen? Well, your algorithm is going to completely ignore that part of your code, the then part, and it'll pass right through without any questions. It doesn't even matter what's going on in the then part of your if-then construction. So, what that tells us is if the if part of the conditional is false, then your statement is automatically true. Now, if the if part of your conditional statement happens to be true, then it's going to look very carefully at the then part of your code. You have to go through the then part of the conditional, and that part has to be true, right? You have to make it so that that's true, otherwise your program will crash. So the only way that you can not get through that part of the code is if the if part is true and the then part is false, and that is exactly what makes the if-then statement false. So let's say I have a conditional statement. If I see a dolphin, then I run away in panic. Now I want to talk about how you negate conditional statements, right? And again, like before, with a negation, we want to talk about when the statement is false. If I can tell you precisely what it means for my original conditional statement to be false, that is what the negation is. All right, so what's going to make that statement false? Well, again, two things have to happen. I have to see a dolphin, and I have to not run away in panic. If any of those things doesn't happen, the statement is automatically true. And not only that, but both of those statements have to be true. It has to be true that I see a dolphin, has to be true that I don't run away in panic. And once again, that's an and statement, right? Both of those things have to be true in order for the negation to be true, and that's an and statement. Which means the negation of if I see a dolphin, then I run away in panic has to be I see a dolphin, that's one of the things that has to be true, and I don't run away in panic. And notice what you don't see in that negation. You do not see an if, you do not see a then. So when you negate an if-then statement and a conditional statement, that is going to be an and statement, not a conditional statement. So when you negate that, it should not have an if or a then in the statement, only an and. All right, so now that we've discussed these things, let's go ahead and work on the activities. The name of the PDF file that's included with this video is called Conditional Statements.